So today we're going to be talking about inverse matrices and identity matrices. And so first we have to start off by talking about what an identity matrix is. An identity matrix is a square matrix with a diagonal composed of ones and the rest zeros. There are different size identity matrices, but every one of them has this diagonal of ones here and everything else is zeros. An identity is something you can do to something else and not change it. So like 5 times 1 is still 5. Well, if I have a matrix, I'm just going to make one up, 1, 2, 3, 4, 5, 6. You might say, well, why do you have infinitely different matrices? Well, it has to do with what you can multiply by. If I'm going to put a matrix over here that I'm going to multiply by, it has to fit within the rules of multiplying matrices. And this matrix has 2 rows and 3 columns. It's a 2 by 3. The only way I can multiply by something over here is if this dimension and this dimension are the same. And so since I have a 2 by 3, the identity matrix that would work has to have a 3 here. So it's a 3 by 3 matrix that I would use to multiply by. If this dimension was a 2 here, then I'd be using a 2 by 2 matrix. If this dimension here was a 4, then I'd have to use a 4 by 4 matrix to multiply it by to get back the same thing I started with. I'm going to show you that this actually does work. So again, this would be any matrix you start with. If you take the appropriate identity matrix, which is not that, I just put a 1 in the wrong spot. Come on, board, help me out. All right. That is the 3 by 3 identity matrix that would work with that. So going back to matrix multiplication that we just worked on, 2 by 3. So if this is a 2 by 3, that's a 3 by 3. The dimensions of my answer is also going to be a 2 by 3, which makes sense because I said if it's an identity matrix, this that I start with, I should get that for an answer over here. So I'm going to get a 2 by 3 for an answer, okay? Don't feel like you have to write down all the work that I'm doing here, but I just want to show you that this does work. So the way matrix multiplication works is you start off with a row and you take it times a column. So you take the first element times the first element. 1 times 1 is 1. Then the 2 times the 0 is 0. 3 times the 0 is 0. So when I add those 3 products up, I get just a 1 there. Then if I take that matrix, that row times the second column of that matrix, the 1 would be times the 0, the 2 times the 1, and the 3 times the 0. When you add up those 3 products, you would get a 2 there. And then if I continue to do that, and I multiply by the next one, 1 times 0, 2 times 0, 3 times 1, I end up with a 3 right there. So you can see that that is how an identity matrix, it does indeed give me those values. If I did that with 4, 5, 6 times each of those, it would also come out to be the same exact values.